Good morning, students. Today I am taking some questions of exercise from your NCERT book, exercise 1.1, from the chapter Relation and Functions. The first question of your exercise 1.1 is saying that if A be any set containing the element 1, 2, 3, 4 up to 14 and relation are defined as R equal to ordered pair xy satisfying the condition 3x minus y equal to 0. We want to check that this relation defined in the set A is reflexive, symmetric, transitive or equivalence relation. So according to the definition of this relation R is given x y 3x minus y equal to 0. So R can be expressed R equal to 1, 3, 2, 6, 3, 9, 4, 12. Because R is defined on the set A to set A. So this relation can be expressed as in the roster form in such a way the element of R 1, 3, 2, 6, 3, 9, 4, 12. So first we check this relation is reflexive or not. Since 1 belongs to A, but 1 not belongs to R. According to the reflexive relation, if each element of set A having the self pair in relation R, here clearly seen 1 is the element of A, but 1 is not belongs to R. Similarly, 2 belongs to A, but 2 not belongs to R, etc. So R is not reflexive. Second, the first is reflexive, second symmetric. How can we check that the given relation is symmetric or not? Since 1, 3 is the element of R, but 3, 1 is not the element of R. This implies that R is not symmetric. Transitive relation. Since 1, 3 belongs to R and 3, 9 belongs to R. This implies that 1, 9 does not belongs to R. 1, 3 is the element of R, 3, 9 is the element of R, but 1, 9 not belongs to R. This implies that R is not transitive. So in this particular question, set A is defined 1, 2, 3, 4 up to 12 and relation are defined as on set A R equal to xy. That means the ordered pair which satisfying the condition 3x minus y equal to 0 are contained by the R. So now we start with R. R is given as xy, where 3x minus y equal to 0. So we take elements of A 1, 2, 3, 4, 13, 14. So take if x equal to 1, according to this condition, y equal to become 3. If x equal to 2, y equal to 6, x equal to 3, y equal to 9, and similarly x equal to 4, y equal to 12. If we take x equal to 5, then y equal to 15. There 15 is not there, so we take only values of x up to 4. Now we check the relation is reflexive or not. Since 1 is the element of A, but 1 is not belongs to our defined relation. Similarly, 2 is the element of A, but 2 is not the element of R, etc. So this shows that R is not reflexive. Symmetric. Let we choose one pair of the relation from relation R. So 1, 3 is the element of R, but 3, 1 is not present there. So R is not symmetric. Similarly, since 1, 3 belongs to R and 3, 9 belongs to R, because when we check transitive relation, we take two consecutive pairs from the given relation. So 1, 3 and 3, 9 are two consecutive relations, but the transitive part 1, 9 is not belongs to R. This shows that R is not transitive. So this is the one example or question based on symmetric, reflexive and transitive relation. In next part, we take some more question based on this type of equivalence relation. Now I am taking one more question based on relation and function. Question is saying that if n be the set of natural numbers and R be a relation defined as R equal to ordered pair xy such that y equal to x plus 5 and x less than 4. So we start the solving of this question. The relation is R equal to pair xy where y equal to x plus 5. That means this relation R containing all those ordered pair, they satisfy this condition, and where x is less than 4. So in roster form, this can be written as R equal to 1, 6 for x equal to 1, 2, 7 for x equal to 2, and 3, 8 for x equal to 3. Now first we check the relation is reflexive or not. Reflexive, that 1 belongs to n, but 1 not belongs to R. Is clearly observing there. The 1 is not belongs to R, so R is not reflexive. Similarly, symmetric relation, let 1, 6 is the element of relation R. Satisfying this condition, y equal to x plus 5, but 6, 1 is not present there. Okay? If we take 6, 1 is there, so this condition is that 1 equal to 6 plus 5. This is not the valid condition, so 6, 1 is not belongs to R. R is not symmetric. Similarly, we take two consecutive pair. If we take two consecutive pair in R, xy and yz. So if xy is there, satisfying this condition, y equal to x plus 5. If yz is there, so confirmly satisfying this condition, z equal to y plus 5. We eliminate the y from both the equations, so we have z equal to x plus 5 plus 5, that means x plus 10, z equal to x plus 10. This is not satisfying. You verify the condition z equal to x plus 5 because xz will be there if z equal to x plus 5. But we have z equal to x plus 10. This implies that R is not transitive relation. So according to this question, this relation only containing all those ordered pairs, they satisfy this condition. So the first condition here we take only a numerical parts of there. If we take theoretically, suppose that x belongs to n, but x not equal to x plus 5. So xx not belongs to R. The definition is saying that of this relation, any pair will be the element of R if satisfying this condition. So if we want to xx belongs to R, x satisfies this condition, but x never be equal to x plus 5, so x not belongs to R, so R is not reflexive. Similarly, y, let x, y belongs to R. This implies that y equal to x plus 5, but x equal to y minus 5 not equal to y plus 5. So yx not belongs to R. So this is a theoretical way of solving this question, but we are take only a numerical part also. So this is the question based on relation and function. Thank you. Now I am taking one more problem based on relation and function. If A be a set of human beings in a town and R with a relation defined on set A in such a way R equal to ordered pair xy, where x is y of y. So from the set of human beings we take a relation R in such a way only those ordered pairs are the element of R in which the element x is the y of y. So we start with reflexive. Let x belongs to A. This implies that x not belongs to R, because x is not a wife of itself. Nobody can be a wife of itself, so xx not belongs to R. This implies that R is not reflexive. Second part of this question is symmetric relation. For checking of symmetric relation, we take one pair from the relation let x, y belongs to R. This implies that according to the definition of this relation, x is wife of y. This implies that y is not wife of x. If x is wife of y, then clearly y never be the wife of x. So this implies that yx not belongs to R, so R is not symmetric. R is not symmetric. Transitive. Let x, y belongs to R. This implies that x is wife of y. So clearly y is male. This implies that there is no possibility of that yz belongs to R. X, y belongs to R. It is possible. So according to definition, x is wife of y. That means y is male person. So there is no possibility of that yz belongs to R. So in this relation, we don't have relation satisfying two consecutive relation. So R is transitive. So this is a different question based on relation and function, in which if we don't have two consecutive pairs in a defined relation, then that relation automatically become a transitive. So this relation is not reflexive, not symmetric, but transitive. Thank you. Now I am taking one more problem based on relation and function. The problem statement is saying that let R be a relation defined on set A of real numbers such that R equal to ordered pair AB satisfying the condition 1 plus AB greater than to 0, where A and B both are the element of set A. So we want to show that here R is reflexive, symmetric, but not transitive. This is a different example in which we are showing that this relation is reflexive and symmetric but not transitive. Solve. How can we start that? The first is reflexive. Let A belongs to A, because this relation is defined on the set A and A is a set of real numbers. This implies that 1 plus A into A, that means 1 plus A square greater than to 0, because square of any real number is non-negative. So this value is always positive and satisfying the relation condition. So we can write AA belongs to R, because according to this condition, if A and B are two elements satisfying this condition, so this pair will be the element of R. Similarly, A and A are two elements satisfying this condition, so A is the element of R. This implies that R is reflexive, symmetric. Now we check that the given defined relation is symmetric or not. Let AB belongs to R. This one pair is the element of given relation. So, confirmly, this pair satisfying the defined condition 1 plus AB greater than to 0. If AB is the element of R, then confirmly this pair satisfying this condition. Here A and B, for every A and B are real numbers, that is the element of set A. This also can be written as 1 plus BA belongs to 0, because AB equal to B. So this implies that BA belongs to R, so R is symmetric. Now we check transitive. We can check transitivity by theoretically, and also we can take numerical pairs. Suppose that let 1 by 2 is one pair belongs to R, because 1 plus 1 into 1 by 2 is equal to 1 plus 1 by 2, 3 by 2 greater than 0, and 1 by 2 minus 1 belongs to R. This implies that 1 plus 1 by 2 into minus 1 equal to 1 minus 1 by 2. 1 by 2 is greater than 0. We take here two ordered pairs. 1 by 2 satisfying this condition, and 1 by 2 minus 1. 1 plus 1 by 2 also satisfying this condition. But 1 comma minus 1 not belongs to R, because 1 plus 1 into minus 1 equal to 0, not greater than to 0. So for 1 by 2 comma for 1 comma 1 by 2 and 1 by 2 comma minus 1 belongs to R, we don't have 1 minus 1 belongs to R. So R is not trinity. R is not trinity. So in this example, this relation which is defined on the set A of real numbers containing all those elements satisfying the property 1 plus AB greater than 0. So we want to check that this relation is reflexive, symmetric but not triangular. Reflexive relation. We take one element of set A, this is confirmed real number. So 1 plus A into A is equal to 1 plus A square. The whole value is always positive because square of real number never be a negative. So AA belongs to R because AA is satisfying this condition. So R is reflexive. Again we take symmetric. Let AB is the ordered pair of R. Satisfying the condition 1 plus AB greater than 0 because AB belongs to A and AB is the element of this relation. So it is confirmed satisfying this condition. This can be written as 1 plus BA because real numbers are commutative. So 1 plus BA greater than 0. So BA belongs to R because this satisfying this condition. Now R is symmetric. For checking the transitivity, we take two numerical pairs defined on set of real numbers. So first pair is 1 comma 1 by 2 of relation R because this pair satisfying the condition 1 plus AB greater than to 0. Similarly, next consecutive pair 1 by 2 minus 1 belongs to R because this pair also satisfying this condition. But the transitive relation, transitive pair 1 comma minus 1 is not belongs to R because this pair is not satisfying the condition of defined relation. So 1 comma minus 1 is not the element of R. So this condition says that 1, so R is not the transitive. Thank you. These are some problems based on relation function. You may take some more questions for practice, and after it you can check that the relation, reflexive relation, symmetric relation and transitive relation are very easy. Okay, thank you.